So, hello everybody. Basically, in short, what Andreas Antonopoulos said. He was my teacher, and I have a ton of respect for him. So, I will talk about public and private blockchains a little bit more. The terminology is confusing in this entire space, but let's just say that public blockchains are blockchains as per their original design, meaning having a decentralized architecture and open for everybody to participate. And that private blockchains are similar, but they only accept participants that are vetted and identified. So one of the questions is, can they coexist and complement each other, or should they be considered competitors? Now, if we remember the original premise of blockchain, it was designed to support a peer-to-peer currency in Bitcoin, and it was designed to support shared data and shared business logic in Ethereum. So blockchain technology enabled open network and uniform access. But not everything can be public. While Bitcoin has some degree of transactional privacy, the issue is even more pressing in Ethereum because it can store arbitrary data, and it even makes business logic visible to all. So in this talk, I will talk about why there are so many differences between those two and why I'm confident about the future. In my mind, they are complementors at the moment, each in their own camp, but in due time, they will become competitors with public blockchains taking the largest piece of the pie. So in my opinion, it is a matter of control. Let's start with accountability. So participants in private blockchains, it's all about names and addresses and bank accounts, but all these lists are against the design of public blockchains. Immutability, so having control over the ability to correct your data due to human mistakes, court orders, or even hacks is a no-go if blockchain is immutable. So it's hard to accept for businesses that they can't update their historical data. I feel that the most painful thing is the control over the code and the development process. And it's because it is the most deep and low-level part of it. So if you have a business need that goes against the design of a public blockchain, and you can't get that feature you need despite whatever money you throw at it, of course, you go and take that software and modify it to your needs, and oftentimes you end up with a private blockchain. There are other aspects, such as regulatory compliance, that we've heard yesterday, great talks about it. So this bridge is getting built from both sides, as the regulators now understand this technology much better than before. Revenue streams. So private blockchains are often backed by profit-seeking organizations. And of course, they need to control their business. Well, in supporting public blockchains, there's no direct revenue from it, besides being a miner, of course. One other aspect is risk management. Now, businesses need to plan for interruptions, and there are established risk management frameworks. But imagine public blockchains being like giant rivers that overflow any obstacle as they come. So any operational risks are dealt with ad hoc groups that come from all parts of the network. Now, in private blockchains, you can't rely on such ad hoc groups. Businesses need established and formal risk management frameworks. Especially financial services, they are required by law to analyze all the risk exposures and to have mitigations plans in place. So I come from a central bank where there's just no way that you would put your the security of your system to a bunch of guys you don't know, and you hope that some developer will take a look at your network and solve your problem. So public and private blockchains are all about disrupting our lives, but they are using such a different technology that they might not both be called blockchain at all. So private blockchains are all about privacy and protecting confidential data. And it's not just about senders and receivers and about the amount of transferred value. It's about contracts, business logic, and metadata. And it's not even just that. Even if you could encrypt your precious data on a public blockchain, you have to be aware that this data is now stored on thousands of nodes all over the world. And what would happen in 5 years if the bug was found in an encryption process? This is the problem of so-called forward secrecy. And there are various techniques that are coming to improve this space. One of them is zero-knowledge proofs that enable verifying the existence of facts without revealing them. But most of these new mechanisms are still new and unproven, despite you might have heard them being used in various coins or something like that. These are very fundamental things that need to take time to really mature. So private blockchains are on the rise for performance reasons as well. You know, the infamous number of transactions per second. And the metric seems to be how to catch Visa. Well, public blockchains are generally not very good at that, not at least yet. But public blockchains are very scalable in another aspect. They can function with many nodes that act as transaction validators or block generators. There can be many thousands of them. In private blockchains, transaction validators are usually around a dozen or so, even much less. So furthermore, private blockchains enable more complex things. Why? Because complex things on public blockchains cost money, and because public blockchains are limited to deterministic contracts. So superior performance of private blockchains is possible due to different consensus mechanisms. So consensus is how we agree about the correctness of our shared ledgers. And there are basically 3 types. The most basic one is crash fault tolerant. And it produces results, correct results, even if few nodes occasionally disconnect, and all blockchain designs support it. The next one is Byzantine fault tolerant. It produces correct results even if few nodes occasionally disconnect or even produce malicious data. So this is the trust thing that we usually mean by talking about blockchain with regards to consensus. And the third part is the thing that came with Bitcoin, the disruption. So incentivized consensus mechanisms work by economically incentivizing participants to stay honest. And such mechanisms enable uniform access. We say they are permissionless, but that comes at a cost. They only function if they allow enough time to pass between blocks of transaction. They are fundamentally slow. On the other hand, they come bundled with a native cryptocurrency that keeps the wheels rolling. With private blockchains, the thing is a little different. Private blockchains are generally still forming, while public blockchains are with us for many years. Private ones, not that many. And an interesting observation is that they're quite relaxed with the adversarial model. Did you know that Hyperledger Fabric doesn't have a Byzantine fault-tolerant algorithm yet? And JP Morgan's famous Ethereum fork called Quorum, there's no BFT there yet. But private blockchains are designed with multiple assets in mind, and their consensus requires no native cryptocurrency. So when Bitcoin came, there was a boom of consensus algorithms. Don't try to read the names of the algorithms, just see the numbers increasing through the years. So ever since 80s, the traditional consensus algorithms were steadily improving every couple of years. And when Bitcoin came, the general public needed about 3 years to grasp the significance of it. And then the numbers of algorithms really took off. And the interesting thing is that the incentivized consensus mechanisms that are suitable for public blockchains also made a reignited interest in traditional algorithms which are suitable for private blockchains. So they share the same idea of disintermediation and increasing security, but they have very different context. On one hand, you have a global audience that has unnamed participants, and you need to trust the technology. And on the other hand, you have named participants which are locked down in your wall, and you need to trust the local legal system. And such thing poses a different technology to be used. So how does this look in practice? There are many things to say here, but I will just mention a couple. So there are many business models that could be made on top of blockchain. Peer-to-peer currencies are a natural fit for public blockchains. And central bank digital currencies are a thing for semi-private blockchains. Decentralized applications, or dApps, seem suitable for public blockchains, right? Otherwise, they wouldn't be decentralized. But what is a dApp? Is every smart contract a dApp? Is it decentralized if it only has 2 developers working on it? So services built on top of an underlying blockchain are good and popular on public blockchains because just think of the ICO frenzy on Ethereum, but I can easily see second-layer services built on top of private blockchains as well. Think of a banking consortium that offers paid access points to their consortium blockchain for indirect participants. So we have talked about different structural profiles suitable for particular blockchain designs through these 2 days. Private blockchains could be used in organizations with delicate data sources, even more so if they have scattered data points around the globe. But blockchains really shine when multiple organizations use it. That's why we see the emergence of blockchain consortiums. But who has the knowledge to say how much decentralization is enough? Some went as far as to say that everything will be decentralized. This makes a little sense if you only take into account the difference in the technology and the different use cases that are made out of centralized and decentralized designs. But the divide is even more important from the governance point of view. Tedious Dryja, who is a Bitcoin Lightning Network developer, emphasized the technological decentralization and social coordination. So while both public and private blockchains share the same decentralized network topology, only private blockchains have a structured coordination and defined processes and such. And this can pose operational risks for businesses because they can perceive it as somehow cloudy. And to that end, Tapscott's father and son propose an indirect stewardship consisting of standards bodies, knowledge networks, and such organizations that are loosely coupled and could help to mitigate these concerns. Therefore, my prediction for the future will be that private blockchains and public blockchains will evolve in different paths for some time to come. And in that time, a couple of things will happen. When public blockchains enable features that they previously lacked, private blockchains could be integrated or absorbed by public blockchains. But more often, though, private blockchains will be anchored to public blockchains. And the reason is simple, because public blockchains are the most secure and highly available system. Remember, Bitcoin just doesn't want to die. And one final thing I want to say, if you could have a private segment inside a public blockchain, this is where the interesting things are happening right now, and I think this is the future. Thank you. Are there any questions? Otherwise, I'd just like to thank University of Nicosia for organizing such an event, and it was really a pleasure to meet all the schoolmates and teachers finally in face. So thank you.